Okay, thank you, Stefan, and hi everyone, and welcome to our presentation about OPC UA over MQTT, a scalable solution. As Stefan already said, I'm Alexander Allmendinger, but I'm very happy that today we have one of the scaling experts here from -Q with Günther. Günther, if you want to introduce yourself real quick. You need to unmute yourself, otherwise we can't hear you.
Sorry.
Perfect.
Yeah, sorry. Good morning and good afternoon, wherever you are in the world. And yeah, I'm happy to be here together with Alexander to give some insights into how OPC over MQTT can scale and what other aspects we try to cover today. But I think it's first up to you, Alex, and take the first part.
Exactly. So we basically split or take turns on describing things, and I just get started with OPC UA over MQTT and the live demonstrator that we already have, and then Günther is showing you like really how to test a scalable solution or scalable architecture with different brokers. So let's get started. When we talk about a scalable solution, of course, first of all, we need to really look into, we need to take a step back and look at the overall architecture and things that you need to address when you actually want to go for a big scale project. And also, of course, when you want to go for a big scale project with cloud connectivity, for example, with MQTT. So thinking about the big picture, we always see this picture here where it basically states or showcasing that you can use OPC UA as a communication architecture, as a communication technology in multiple areas of your overall environment. And then the question often asked is, why should I go for such a harmonized approach, a holistic approach with OPC UA? Why shouldn't I rather concentrate on like specialized protocols, specialized solutions for one of the aspects in my architecture? And of course, there are several things that you need to look at. And this is when you look at the overall architecture of OPC UA. One of the very big advantages is, and that is what makes it that scalable and that easy to adopt, that you don't need to have project-specific development. So there's no real coding, it is rather a configuration piece. Also, when you have a holistic approach with OPC UA, a very important detail is that you do not need to transform the data or the metadata into other technologies, because often there are some details in this transformation that are not making it that scalable, and I'll get to that in with the next slide. But there are other aspects as well that you always need to consider, that you always need to keep in mind, and that is, for example, when you have the holistic approach, you really have the access to the semantical information. So yesterday we learned a lot about the information modeling from, for example, Wolfgang Manke with defining domain-specific, industry-specific semantics, so definitions, type definitions to describe assets. And you always need to have access to this kind of information, right? Because you need to understand the data that you're receiving. And with OPC UA and a big architecture, or all the architecture that is given to you with OPC UA, you always have access to the semantical information. Even if you don't have direct access to the physical asset, there's a solution for it, which in that case is the cloud library that potentially you already have heard of. But if not, there are online recordings describing the concept. So I'm not going to dive deeply into it, but there are always mechanisms to gain the data that you potentially don't have direct access to. There's even more than that. So we have with OPC UA a solution or specification which describes the onboarding of devices. So when I bring a new device to the system, how do I need to act? What do I need to do? Like application or device registration, the discovery of these new devices in the network, but also the certificate management. And certificate management, especially when considering security. Yesterday, we also heard a lot about security, and also from our friends from the FBI, why they consider OPC UA that important. And a big chunk of that is really the information modeling, but rather the security for the FBI. So you need to do the certificate management, because MQTT also is utilizing certificates to manage the security. So you need to get the certificates from A to B. You need to renew them. And OPC UA provides you mechanisms to do this security orchestrations, to do this management. Same for the security configuration, like user roles or authorization configurations or details. You always need to keep these things in mind as well, and they need to be harmonized throughout your architecture. And with all of that being in an open, interoperable standard, the big benefit is you're not being locked into any vendor solutions anymore, right? Because it is an open standard. So even once you decided to go with OPC UA as in a holistic approach, it really opens yourself up. You can have more flexible architectures, and this really gets you into a scalable solution. Now, I mentioned that the transformation of data and metadata is sometimes a little bit difficult, and there's a reason why this is the case. When you think about OPC UA data, then you're not only getting like a data value, and you're also not only getting like one timestamp, but in fact, you have access to many more details. So for example, you get some engineering units if you need to, so you can access the exact unit of the value. You have status codes, which are always transmitted with an actual data value. You have multiple timestamps. You have the relationship, which is not directly, of course, always sent, because that would be a big chunk of data, but it's present, it's available. And when you transform all of this information to another standard, to another technology, often you don't have the necessary fields to maintain this information. So you lose the information. And then you transmit it to higher layers, you transmit it to other applications. And what you have at the end is you store the data points, you hopefully also still have stored the timestamp, but you're missing information that you need to analyze the data to do some data science at the end. So what you're now doing is you're re-adding what you already had before. And with having a holistic approach, you don't need to do that anymore, because the semantical information, the relation to the physical data or to the physical asset or to the process behind it, that is still present. And this is like the big benefit of staying within one ecosystem, but using different protocols to transmit the data. And this is like the big power when you think about the modular architecture of OPC UA, right? So we have the upper layers with the information modeling pieces, with the semantical meaning, which is completely independent of the actual transports. This is exactly what Jim Loof yesterday taught us, right? So he explained how you can model your stuff and how the modeling and the representation of the data is actually independent of transmitting it from A to B. And I don't want to go into all the details here, but when you look at the modular system, what you actually see on the right bottom side is exactly this mapping for publish subscribe with MQTT and different options to get for the encoding to get your data to the cloud. So we want to focus on MQTT for now, so we don't want to spend more time on actually looking like at the big picture of the architecture, but this is always important when you want to think about scalable solution or when you want to discuss scalability. When looking at OPC UA over MQTT, the reason why you have this mapping, why OPC UA defines a mapping to this transport, is because MQTT is very successful for the cloud connectivity. It's basically used in most of the IoT and IIoT architectures. There are two major versions which are being utilized in the industry, which is MQTT 3.1.1 and also MQTT 5.0, and they are very present. And because of OPC UA has mapping to both of those versions, and also there are some details in it that I don't want to get into, but OPC UA basically always has implications on the actual MQTT payload as well as on the variable header if need be. This whole mapping was already initially released in 2018. That is what Stefan already mentioned before. So and also one of the very early adopters here with Microsoft, they were pushing for having this mapping and also implementing and integrating it for their cloud connectivity. Now, because of this flexibility, because of this scalability and interoperability that OPC UA over MQTT provides, this actually makes end user communities like the Open Industry Alliance, UMADI, Spectaris, and others actually focusing on OPC UA over MQTT for the cloud connectivity, because they see the big benefits of having this holistic approach. We already talked briefly about the encoding, and I don't want to dive into a lot of details here, but there is something that is important to know, and that is why I want to highlight a few things about the different encodings with JSON or UADP. So when you want to have an efficient communication, you can utilize a UADP encoding that really saves you the size in messages. And it also allows you to enable the full OPC UA Process Security, because now you are in the world of OPC UADP, and that provides you application-to-application security that I just will get into with the next few slides. The problem with this encoding is that it really requires the knowledge of OPC UA on both sides. So you always need to have proper encoders on the publisher as well as on the subscriber side. Now, with JSON, there's an alternative solution which is really like textual based, and that allows for an easier integration even without a special encoder, because now you get text or you receive text that allow you to do like custom pipelines to pull out information of this well-structured JSON message. So even without having a full-blown OPC UA subscriber, you can theoretically pull out data out of those JSON messages. Of course, you don't have the full flexibility. You cannot adapt to dynamic changes in the messages and things that are supported by OPC UA, but at least you can have easy integration for a project where the subscriber does not have the OPC UA knowledge yet. Now, when looking at MQTT security, I already mentioned that certificate management is an important piece that you need to consider, and that is also true when just looking at MQTT, because what MQTT is doing, it is providing you a TLS security between two direct peers. That basically means in our architecture here, between the IoT agent and the broker, there's a TLS connection, and between the broker and the subscribers, or between the two different brokers, there are TLS connections. So you always need to have certificates in order to manage this trust relationship. The problem that you have potentially is that the brokers or the applications in between, they always have full access to all the data, because the security is just for the communication piece. Now, what I already indicated is that together with MQTT and UADP, that basically enables you for OPC UA security. Now, certainly what you're receiving is you have the TLS security brought by MQTT between the IoT agent and the broker and the subscriber. But now you also have a direct security relationship between the IoT agent and the subscriber if you want to have it. So theoretically, what you can do is you can send encrypted communication via MQTT without the broker even understanding what's the content of the data. And this is what you basically enable yourself when you utilize this strong combination. When looking at scalable solution versus efficient solutions, unfortunately, there's always a trade-off, right? So when you want to have scalability, you need to, like scalable solutions like you do with OPC UA, it is really about the easiness of reusing codes, architectures, concepts, and ideas for different deployments. So what you don't want to have with a scalable solution is that whenever you onboard a new device, you need to use a new connector, you need to develop something new, you need to create a new pipeline. All of that is stuff that you don't want to do for a scalable solution. And luckily, OPC UA provides you mechanisms to automatically discover these things. The problem is whenever you have such scalability, that also means that you're not that efficient anymore, because the most efficient way to transmit data is to send a byte blob, right? But then always both sides need to exactly understand what the byte blob is about. So whenever you increase scalability, whenever you increase interoperability, you always reduce efficiency. There's unfortunately always a trade-off. Now, when looking at scalable solutions, what of course we also often get asked, why is OPC UA not mandating a certain topic tree structure for the data communication? And that is because OPC UA provides interoperability through different mechanisms. We don't need to have the standardized topic tree for the data transmission. And also what we learn from end users in our working groups is that they know how they orchestrated their facilities and their devices. So they want to maintain this data structure topic tree. But OPC UA over MQTT still provides you interoperability and the scalability, right? This is being done throughout the standardized data models that we learned about like yesterday, through the standardized payload formats that are specified, but also throughout the standardized topic definitions or topic trees requirements for specific use cases. And just to show you how this will actually look like, I want to pull out one example, which is the use case of the automatic publisher discovery. So the way that this basically works is you have a publisher and you mandate a certain topic tree structure for specific messages, like a status message or an application message. Now, what this provides you is you can have a generic condition monitoring system or a generic dashboard subscribing for those specific use case topic trees, pull out the information, and with that, creating an automatic onboarding of publishers and getting the status of these publishers. And this is exactly what Microsoft, as an early adopter, already realized for their dashboard. So they already integrated that idea and showcasing that as a early prototype here. And the big benefit with utilizing OPC UA for that mechanism is actually that, as we're always saying, OPC UA is domain agnostic. It is not specific for a very specific industry. So with having those harmonized information models, for example, the device descriptions, together with those predefined topic tree structures for some use cases, this actually really allows you to generate generic dashboards and onboard devices automatically for all the different industries. Another question which is always or often then raised is, how big is the integration effort? How difficult is it to actually get this OPC UA over MQTT implemented? And the good news is, yes, there are a lot of details to it, but when you think about what is being provided to you through the different libraries and mechanisms like the Ethernet chip, right? You never worry about how to actually put the signals on the wire. That is just provided to you. Same is for some very basic networking capabilities, which are provided by the OS or network libraries. So you integrate or extend that with your MQTT library. You have the OPC UA SDK, which provides you all the encodings and everything. And then you have your own code that you actually need to develop. So you need to do some integration work to bring it to your hardware platform. You need to work on the data modeling. But also here, the good news is if you already have OPC UA in your device, that actually means you can easily extend it with this additional use case if the OPC UA SDK you're using is actually supporting MQTT already. So it is fairly simple to implement it or integrate it into your products. And this is exactly what we are demonstrating in our demonstrator. And I want to highlight one here real quick, because that was the very first one that we created and publicly showed on a trade show, which was a process demonstrator for Ethernet APL devices organized by the company Samsung, who then created this cloud connectivity with OPC UA over MQTT just 2 weeks before the trade show. So they just integrated that very quickly in order to have the cloud connectivity and showcase this potential with the easy extension of OPC UA. Starting from there, we extended the demo architecture that we have. And if you look at the demo architecture we have today, you will find mostly two different kind of solutions or approaches in the architecture of the demonstrator. You'll find the solutions where the MQTT publisher, so OPC UA over MQTT, is directly integrated into the application, which also does OPC UA communication as an OPC UA server. So in that case, you already have the data modeling and everything, and it was just extended by an additional piece to get the data to the cloud. If you want to look at an example for that, luckily the IIoT Starter Kit, which I have a final slide at the end as well, is actually showcasing and describing that to you. The other solution that there is the gateway solutions, and that is really for the vendors who decided that their devices cannot maintain too much resources on different communication aspects. So they want to focus on the OPC UA server and then provide an additional piece and a gateway, which is actually transforming the data from collecting it via an OPC UA client and then transforming it into the MQTT world. And good news here is there are many open source solutions out there which provide you that capability, which act like such a gateway, as well as several commercial products that you can leverage from. Now, when you look at the demo as it is implemented today, what you actually see is we have a lot of different publishers or devices from different industries. All of them send their data, OPC UA over MQTT data, now to a HiveMQ broker, which is in the center of our architecture. And from there, it will be transmitted to the dashboards to actually showcase the thing. And what you see here from looking at the vendors is that there are actually vendors from all different industries. You find like robot controllers, you find PLC vendors, but also device vendors. So today we have more like 35 participating companies in the demonstrator. One group that I just want to highlight real quick, because we also heard from them on the very first day, is the laboratory and analytical device industry, the LADS, that you heard about on the first day with the cobot example from Matthias Arnold. And the interesting story here is that just like with a 2 weeks notice, 18 companies managed to onboard their devices with OPC UA over MQTT to the demonstrator 2 weeks ahead of the Hanover trade show. And this is like a big success and really shows how easy it is to adopt the solution and how scalable that is, because then the dashboards were easily extended with those new vendors to showcase the data being sent. The other product that I just want to highlight, because that is one of the most recent publishers being added, is the Chevron IO Link Gateway. And so this is really collecting data from an IO Link device, transforming it to OPC UA over MQTT, and providing the cloud connectivity with that. And the interesting thing here is for Chevron, this use case is that important that they actually created an own demonstrator, which they exhibited at the SPS Italy in the center of their company booth. So a very strong commitment here. Like I said, if you want to dive into more details, what you can actually do is you can look at the IIoT Starter Kit, which is available on GitHub and really shows how all of this works together. To get a feeling for OPC UA over MQTT and how scalable it is. And of course, what you want to do is you want to test your integration. You want to test and verify the scalability of your overall architecture, of your overall solution. And this is exactly where I'm very happy that we have HiveMQ today. And with that, Günther, I would like to hand it over to you to actually show how you can utilize the environment to test such a scalable architecture.